Hey there, this is Mrs. Chabot. This is a video for my Calculus 3 class. There was a question about this problem from the problems in my math lab. I believe this was number 12 in section 15.7 is 15.7.51. Find the absolute maximum and absolute minimum of this function f of xy on this region, xy, such that x minus 1 squared plus y squared is less than or equal to 1. So just like in single variable calculus, we saw a continuous function is obtains its absolute maximum and absolute minimum on any closed interval. So it's the same thing here. If I have a closed bounded region and a continuous function, then I know that this function will have an absolute maximum and an absolute minimum on that region. Okay, so let me just have a little sketch of the region R. So this is a disk centered at 1, 0 with radius 1. Okay, so this would be the boundary. And then the region R would be everything in there, but I don't want to color it in because I want to be able to point at it. All right, so here's my region R. So the absolute maximum or the absolute minimum could occur at a critical point of the function f, or it could occur on the boundary. So those are the options. Let's start with the critical point, or points if there are any. Okay, so to find if there are critical points, we would find our partial derivatives and set them equal to 0. So f sub x equals 4x minus 4. Why don't we go ahead and set that equal to 0 right now and get that that happens when x equals 1. And let's look at f sub y, which equals 10y. And if I set that equal to 0, we see the only solution for that equation is y equals 0. So there's only one critical point, which is 1, 0. And if I look at 1, 0 on my graph, I see that that is in the region R, so that is potentially where the absolute maximum or minimum occurs. So let's see what the function value is right there. So I'll look at f of 1, 0. So I get 2 minus 4 plus 0 plus 5 gives me 3. Okay, so the function value at that point in the domain is 3. But now we need to consider what's going on the boundary. So basically the boundary has essentially critical points along the boundary, or possibly has critical points where there could be relative minima or relative maxima of the function. So let's just take a look at this circle on the boundary, x minus 1 squared plus y squared equals 1. And I could solve for one of the variables. In this case, it would be pretty simple to solve for y squared, which equals 1 minus x minus 1 squared. So the reason I did that is I want to be able to write this function in terms of one variable. So in this case, I would just write it all in terms of x. Okay, so f evaluated at, I won't even write it down. So f evaluated on this boundary, I will call g of x. So that would be 2x squared minus 4x plus 5. Instead of y squared, I can write 1 minus, I'm going to start simplifying this, x squared minus 2x plus 1. Okay, so that's my y squared, right? Plus 5, so I get g of x equals 2x squared minus 4x plus 1 minus 1 cancels out. So I have 5 times this would give us negative 5x squared. And that'll be negative 5 times negative 2 gives us plus 10x. Okay, and then plus 5. And finally, I get g of x equals negative 3x squared plus 6x plus 5. So notice this is the function values of this function, but specifically on this boundary. Okay, so now let's see if we have essentially critical points there. So g prime of x would equal negative 6x plus 6. We'll set that equal to 0. And we get x equals 1. Okay, so remember y squared equals 1 minus x minus 1 squared. Okay, so I could plug in 1 and simplify here, or since I graphed this pretty carefully, I can see that this is 1, 1, and this is 1, negative 1, but I would get the same thing plugging in 1 here, right? I'd get y squared equals 1, so y equals positive or negative 1. Okay, so the points of interest on the boundary would be 1, 1, and 1, negative 1. But since there's no y's, it's just y squared, I'll get the same thing either way. So let's take a look at f evaluated at positive or negative 1. And we get 2 times 1 minus 4 times 1 plus 5 times, in either case, that would be 1 plus 5. All right, so let's see what we get for the function value. Negative 2 plus 10 is 8. So I get that f obtains the value 8 at this point, 1, negative 1, and same thing here at 1, 1. Okay, so at this point, those are the only possibilities for maximum and minimum values, and I can see the largest one is 8, so the absolute max is 8, and it's obtained at 1, 1, and 1, negative 1, and the smallest function value we saw earlier at the critical point, so the absolute minimum is 3, and that was located at 1, 0. And that's it. Okay, well, I hope that was helpful. And I'm also going to do a video for number 13, which is similar in case that is of interest to you.